Converting moles to number of atoms. How many atoms are in 2.12 moles of propane, which is C3H8? We are converting moles to molecules to atoms.
So first I like to write down what I know and what I don't know, the known and the unknown. And under the known I have the number of moles equals 2.12 moles of C3H8. And then 1 mole of C3H8 equals 6.02 times 10 to the 23rd molecules. And this number is Avogadro's number. And you always use it when you're dealing with atoms and calculating the number of atoms in a formula. So, and then over here under the known as well is 1 molecule of propane equals 11 atoms. And we got this by adding the 2 subscripts, 8 and 3. Then the unknown, we have the number of atoms in 2.12 moles of propane. So first you set up the conversion factor. We did 6.02 times 10 to the 23rd molecules of C3H8 over 1 mole of C3H8. And then we make another conversion factor, 11 atoms over 1 molecule of C3H8. And then this is the final one. The final conversion factor is 2.12 moles of propane times 6.02 times 10 to the 23rd molecules of propane over 1 mole of propane times 11 atoms over 1 molecule of propane. And then you would multiply and cancel. Some of these things cancel, like the moles cancel and molecules cancel, and you end up with 1.40 times 10 to the 25th atoms of propane.
Converting moles to mass. What is the mass in grams of 9.45 moles of aluminum oxide?
So just like last time, we're going to write down what we know and what we don't know. And what we know is that the number of moles is going to equal 9.45 moles of aluminum oxide. What we don't know is the mass of aluminum oxide, the mass of 1 mole of aluminum oxide. So again, you have to set up a conversion factor, just like last time in the last problem. And this one is 2 moles of aluminum times 27 grams of aluminum over 1 mole of aluminum. And notice that we're doing each thing separately, aluminum and oxygen down here. So you have to set up a conversion factor for each separate part of the compound. And then this equals, the aluminum formula equals 54.0 grams of aluminum. So now we have the mass of aluminum. And now over here we have 3 moles of oxygen times 16 grams of oxygen over 1 mole of oxygen equals 48. Now notice the number, you know how many moles to put by the number of aluminum ions there are in a chemical compound. So 2, that's why you have 2 here, and there are 3 oxygens, that's why you have 3 here. And then the final, the last step is just adding the mass of aluminum and the mass of oxygen together, and you get 102.0 grams of aluminum oxide. So that's how you convert moles to mass. This lesson is on converting mass to moles. How many moles of iron 3 oxide are in 92.2 grams of iron oxide? So now Caroline's going to explain.
Okay, so our unknown is moles of iron 3 oxide, and our known is 92.2 grams of iron 3 oxide. So now you need to find a conversion factor, which is 1 mole of iron 3 oxide is 159.70 grams of iron 3 oxide. And you find that by finding the molar mass and multiplying it by the subscript, and you come out with 159.70. And then you multiply 92.2 grams of iron 3 oxide by 1 mole, and then you come out with 92.2 moles of iron 3 oxide divided by 159.70, and you come out with 0.577 moles of iron 3 oxide. This wiki is by Caroline Hill and Austin Penta, period G.